The topic discussed in this video will be the chain rule. The chain rule is used to differentiate compositions of functions or to find the derivative of a composite function. Composite function is h of x is equal to f of g of x. The example that we will use is y equals sine 2 of x. The complete equation is f of g of x is equal to sine 2 of x. We work these problems from the inside out with g of x being equal to 2x.
The derivative of a composite function h of x equals f of g of x is represented by h prime of x equals g prime of x times f prime of g of x. As seen in the Leibniz notation, y equals f of u and u equals g of x. That could be simplified into f of g of x, which can also be written as dy over dx. There are 4 steps to using this chain rule. First is to find the individual components of the function, meaning f of x and g of x. The next step is to find their derivative, and which will be implemented into our next step. After doing this, you use the formula of f prime of x equaling f prime of g of x times g prime of x to discover your solution. Lastly, to simplify your function, you either use the trigonometric functions, identities, and or multiplication.
For example, h of x is equal to 4x squared plus 3 raised to the 7th power. We work these problems from the inside out, and the inside would be g of x is equal to 4x squared plus 3, and then f of x is equal to 4x squared plus 3 raised to the 7th power. The g prime of x would be 8x, and the f prime of x would be 7 times 4x squared plus 3 raised to the 6th power. So we move on to the h prime of x, which is equal to 7 times 4x squared plus 3 raised to the 6th power times 8x. Combine 8x and 7, you get 56x times 4x squared plus 3 raised to the 6th power.
Now to review, the chain rule is used to differentiate the composition of function or to find the derivative of a composite function. The example given of sine 2x perfectly illustrates the beginning steps of the chain rule by dissecting the initial function into its original parts, which is represented by h of x equaling f of g of x. By finding the derivative of the function through the process, which can be traced back to section 3.3 and 3.5, we can proceed to the next step. The process we use to find a derivative is work inside out, meaning to find the derivative of the innermost function with respect to x, and working your way out, eventually completing the process while always keeping the function in respect to x. The initial function, represented as hs, then goes through the derivative process using Leibniz notation, which is dy dx. It becomes h prime of x equaling f prime g of x. It is important to note that the final step of the process, which is confusing the sum, is to simplify the derivative represented. I would like to thank Ashley F., who is the researcher. She was responsible for the accuracy of mathematical theory in the dialogue. I'd like to thank Blake L., the writer, who was responsible for the written dialogue, and Keyshawn S., the producer, who was responsible for all aspects of the video, production, and compliance with all instructions.